Hello, grade 5 teachers. Let's have a look at some ways that you can connect computer sciences into your living systems unit. We know that the computer sciences organizing idea all the way from kindergarten through grade 6 has to do with creativity, design, and computational thinking. In grades kindergarten up through grade 2, students are learning a lot about instructions, how to interpret them, how to follow them, and how to create them. These are some of the skills that you might need to cover with your students before you're able to fully reach the grade 5 skill, where we're talking about students justifying a design that could be used by a human or machine to address a challenge. So in grade 5, students are really being asked to think about creating programs for machines. We're talking about coding computers and robotics, and all of the ways that they've learned about dealing with instructions in the prior grades are going to really start to connect when we're having these conversations about designing programs for machines. Your computer science is full of a lot of knowledge. I've highlighted some areas over under the knowledge category where it's talking about computer programs and code images, audio, video, presentations, and web pages. So while our topic is computer science, and most of these things would definitely be made on computers, they're definitely not all computer programs or connected specifically to computer programming. So when we're creating artifacts like slides presentations on living systems or any topic, we're also bringing that computer sciences knowledge into our other areas. Students will be learning about computational thinking. Specifically in grade 5, you're going to be working through those steps and explaining and talking about what the pieces of computational thinking mean in a lead up to grade 6, really focusing heavily on the abstraction piece of computational thinking. So by the end of grade 5, we want to be sure that our students have a really solid understanding of what the different parts of computational thinking are, why we use it, and how we use it. And you're going to teach this explicitly to your students probably early in the year as a specific computer science topic, but then you're going to want to make connections back to that computational thinking as often as you can and relate it to as many other topics and things that you're doing with your class to cement it in with your kids as much as you can. Creativity starts early on in the curriculum language, teaching students how to find a different path to the same place, coming up with new ways to solve a problem, looking for different ways to do the same things. This is really just encouraging students to be creative when we see a problem and think outside the box of ways that we might solve that problem. We use creative thinking when we're going through the design process for sure. As you're teaching students about doing these different pieces, make connections to other areas of your teaching and classroom daily routines whenever you can, particularly when we're teaching students how to empathize and what that means. Anytime we can connect that into what we're doing in class will help students understand for their future learning. Computational thinking is the other piece that we want to explicitly go through now and show students what these pieces are, have conversations when we're doing decomposing, talking about how that is computational thinking and that is how computers and machines think, and making those connections to how when we are thinking like machines. So your grade 5 students are being asked to learn a lot of content in this living systems unit. You can definitely bring in some computer sciences activities when we're learning the different parts of the different systems. This is a labeling activity of the digestive system, and it doesn't matter what system we're looking at here. The computational thinking is going to be applied in the same way, and because we want students to think about that we're doing computational thinking, we can do this activity, but then we can extend by adding on, how do we do decomposing when we did this? Well, for one thing, we're only looking at the parts of the body that are involved in the digestive system. Everything else isn't even in this image. We've just honed in on what we need. So now we have done some pattern recognizing because we recognized which organs are a part of the digestive system. Maybe we didn't pick them out, but this is being done for us. So we can just have a conversation about how this has been abstracted down into the simplest form. These are the pieces we need to know to understand how the human body digests and deals with food. And then if I ask students to say, put this into order, now we're moving into actually building an algorithm. So here are the steps of processing food through the human body based on what you know about the, or put these in order. I'm checking off, yep, they understand how food is digested. I'm also covering that they are creating a set of instructions that could be followed by a human or a machine to complete a task. This is my computer science skill. We're putting steps in order. We're building an algorithm. We're going to talk about that. We're going to make that connection. Students, during this activity, how did you use computational thinking? And then we know that we're going to be engaging in that computational thinking. And if we ask students to go beyond and create something of their own design, or to maybe do this process with one of the other systems, now that we've done this with the digestive, we could be engaging into that design process as well. Moving even further, we can go into a scratch activity like this one that I have created specifically about the digestive system. So you can have your students use the scratch cards and the template that I've already made to redo this specific system. You could use this as a starting place and have them go ahead and create the other systems. You could give students, use this as an exemplar, and then give students some choice, have them head off and create their own sprites and design this whole thing from scratch. By grade 5, there's a good chance that your students have maybe already used the Scratch interface before and they're familiar with it. They may be comfortable going ahead and starting right from the beginning and building this thing right up. Definitely, if they use the scratch cards that I've provided and the template and do this digestive system activity, they would be ready to do some of the other systems as an activity. So they would be showing you what they know about living systems and then also showing you what they can do in the computer sciences area. They'd be creating an artifact, they'd be designing an algorithm, and also probably having quite a bit of fun. All of my scratch cards come with the blocks step by step that need to be added to the sprites that are already included in the pre-built templates. I create all my stuff in Canva. If your students are familiar and have access, they would definitely have no troubles creating their own sprites and backgrounds for their Scratch projects in Canva also. So that is a way that they can take this beyond and cover the other concepts where there aren't necessarily templates created. If you teach them how to do it, you'd probably be amazed at what ideas they would come up with and ways that they could show you that they understand their science concepts through a Scratch project. For example, this is not a project that is created, but again, knowing the different transport systems of plants, you could, these assets right here came out of Canva. So again, if your students have access, they could find these things in Canva, create those sprites, and then add in some animations and code to create some type of a game or an animation that talks about the transport systems of plants. So showing you what they know about this living systems, but then also tagging on these skills and procedures from the computer science, just giving them lots and lots of practice, because we know that those coding skills are really important and going to give students some extra leg up into the work world when they get there. Those are some ways that you can connect computer sciences into your living systems unit. I hope you enjoyed.